This next unit of study, we will look at slope-intercept form, standard form, point slope form. We'll look at so much involving linear functions. And we'll start today with just looking at, well, how do you plot an ordered pair correctly? What are the quadrants? And as you see, how we can compare different equations that have different slopes, different y-intercepts, all in relation to the parent function. We'll discuss that in just a moment. And then finally, we'll take an equation and we'll look at some ordered pairs and we'll determine if those are solutions to a linear equation. So first off, we'll look at just some application to functions and linear equations. With this problem, we've got shipping, and this could be whether we deal with Amazon or whether we're dealing with just the U.S. Postal. This says that the item is a $5 insurance fee and a $6 per kilogram on the package. So if it was an equation, we would say y equal $6 per kilogram with an initial fee of $5 for the insurance. So it could be a small package, maybe not even quite a kilogram, but the insurance that's included would be $5 for that shipping. So the rate in this case is the coefficient. And the coefficient is our m value or our slope. And then we've got the value here. This would be a positive 5, and that would be your initial value or your y-intercept. Here we were looking at a Sprint phone. So let's say the Sprint phone set iPhone 7 is 32 gigabytes. It's currently available for $0 down on approved credit and $27.09 with the lease or installment. So basically, you're going to pay $50 for the plan and $27.09 monthly charges for the iPhone. So something like that would look like $27.09 per month and $50 for the plan. So X in this case would be each month, and Y would be the cost. So 50 would be your y-intercept, and $27.09 would be your rate. You also look at Amazon if you wanted to look at different types of shipping. And I just pulled this from Amazon website. Price can vary in size and weight. And we're looking at $2.99 per item or $7.99 per item. Those are obviously things where we're looking at one-day shipping, or if we wanted, soon, a Saturday shipping or no rush shipping, then you wouldn't need any type of extra cost. And a lot of that's due to being a Amazon Prime member. For the fitness folks, if you looked at Planet Fitness around that's just one type of gym that's in our area. You can see that they promote $19 per month and as low as a $10 startup fee. So what we would have is $19.99 times X plus $10. So $10 would be your initial fee, and $19.99 is your per month amount. And you've got different types of plans that this would be as low as a $59 startup fee and $15 per month. And here is a $49 startup fee at $10 per month. So different promotions, different offers, different prices provide different aspects. So when we're talking about graphing, this would be our first quadrant, okay? So everything in this quadrant, this being X, this being Y, our movement in graphing would be to the right and up would put us in quadrant 1. Notice the positive, comma, positive, that would mean a positive amount and a positive amount. Quadrant 2 would be moving left and up. Quadrant 3 would be moving left and down. Notice the signs, negative and negative. Those would be the signs of your ordered pairs. And quadrant 4 would be to the right and down. So those are your directions. Positive, positive. That just means you're going to go right and up to put you in quadrant 1. If you wanted to go left and up, so left and up would put you in quadrant 2. If you needed to go left and down, then that would put you in quadrant 3. And finally, if you were a positive going to the right, negative going down, that would put you in quadrant 4. Notice that the direction is counterclockwise, and that typically falls in line with how we measure degrees and angle measurements. So that opening being a degree measure from 0, opening this way. And so, or we have an angle degree measure that's opening this way. Here's 0. So that would be somewhere in quadrant 2. But that's how we determine our quadrants, is in that counterclockwise motion. So several points. If you look at the point 2, 5, I would ask you to see, well, what quadrant would that be located? Well, that would be positive 2, positive 5. So that'd be right and up. That'd put you in quadrant 1. Negative 2, 5. Well, that would put you going left and up. So that puts you in quadrant 2. Negative 2, negative 5. That would have you going to the left and down. That would put you in quadrant 3. And then negative 2, negative 5 would, or excuse me, positive 2, negative 5 would put you positive, and then a negative, that puts you in quadrant 4. Where we have some red flags, or just understanding that these are not in a quadrant. And what that means is where you have a x-intercept, which is an x value and y is 0, or you have a y-intercept, that's when x is 0 and you have a value for y. We will be looking at these heavily, this y-intercept, when we are writing equations that fit our slope-intercept form. Second part of the lesson is we'll look at the fundamentals of writing something in a slope-intercept form, graphing horizontal and vertical lines. This is an arithmetic sequence. It's where a lot of it begins. It's when we're saying that the sequence begins with some value A, and N is the term in that sequence, and D is your common difference. And that's where we'll be looking at the slope. This is a very, very formal way of looking at a linear function, is using the arithmetic sequence form. We also have this form here, which we will introduce for this week, and that is our slope-intercept form. M is your slope. You will have a value, and that value could be an integer or it could be a fraction. And then your y-intercept, or B, could be, that is your y-intercept, and that value could also be an integer or a fraction. Now we look at things called the parent function. As you see, I've got graphed here. This is just y equals x. And I'm just going to share my calculator screen. And if once I go to, once you go to the calculator and you type y equals x and you graph, what you see is an equation that goes through the origin that has a slope of 1 to 1. So for every y value you increase 1x, 1y, 1x, 1y. It's a stair step. And that would be your parent function. So let's go back. And let's say, well, what happens if we have y equals 2x, or y equals 5x, or y equals 10x? All of these have something in common. What they have in common is they all have a y-intercept of 0. You will see that all of those equations will actually go through 0. It's the slopes or the rates which are different. So what they have in common is a y-intercept of 0. So that's y equals 2x, y equals 5x, and y equals 10x. So let's look at those through our calculator. And here's your parent function. So if I type in my red function will be y equals 2x. And notice how that changes with the parent function. Well, the parent function is a 1-to-1 rate. The red would be a 2-to-1 rate. So the blue line is a 1-to-1, the red line is a 2-to-1. If I go down to a black line here and I say 5x, what do you think would happen? It's steeper. So as the rate increases, the blue was 1-to-1, the red was 2-to-1, the black was 5-to-1. So you can only probably just guess of what 10-to-1 would look like, and it would be extremely steep. So notice from the parent function, the slope increases, the steepness increases as we changed the slope from 1 to 2 to 5 to 10. It's getting larger, slope's getting larger, so therefore the slope and the steepness of the line is increasing. Notice with these three, what do they all have in common? And you guessed it, it's the y-intercept of 0. They all will pass through the origin just like the parent function, except there's one difference amongst all of these, and you see it, there's a negative coefficient. So if we go to our calculator, and I'm just going to clear these out. And so what if we have negative 2x as compared to the parent function? Parent function's in blue, and notice that it is intersecting the blue, but it's not going the same direction. Reason? It's because our intercept is that the line is dropping 2 units for every 1 x value. For every 1 x value it increases, if we look at the table, for every value that x increases, what's happening to the y? Well, it's decreasing. the parent function was 1 to 1, as you notice. Notice the y value is -2 to 1, -4 to 2, -6 to 3. That ratio results in -2. So let's do another one, and we notice that if it was -5x, it should be very similar to the last example we looked at. It's getting steeper, it's just that it's negative. And then one more, if we go with -10x, we notice that it's going to be even more steep, but still negative. Now, parent function. Again, here's our parent function, and now notice what we have with these examples. 4/5, 3/5, 2/5, 1/5. What do they have in common? Well, you don't see this intercept on the last few examples. We don't see that intercept. So if we don't see it, then what we have is just a slope with an intercept of 0, which we just don't write it when the intercept is 0. So let's look at all of these and see how they compare to the parent function. So I'm going to clear out, and something that I like to do, and that is I just like to put the slope in parentheses. So 4 divided by 5x. Now let's see how this is in comparison to the parent function, which is in blue. Notice that the red one is not quite as steep as the parent function, which means if the blue line is 1 to 1, this one's less. That means it's less than 1 to 1. It's actually 4 to 5. So how about 3 divided by 5x? And if we graph that, we're going to see that it's smaller, because 3 to 5, that ratio is 60%, or 6/10. It's smaller than the red, which is 4 out of 5, or 80%, or 8/10. This blue one would be 1 to 1, or 100%. So 100%, 80%, 60%. What's happening is that we're still a positive slope, but it's not getting as steep. It's actually flatlining. It's actually getting closer and closer and closer to 0 as a slope. So the next screen, we would see that all of these are very similar to the screen before, except what do you notice? The slopes are negative, and the y-intercept is still equal to 0. So we would see the same that happened in our previous screen with the calculator. It would just be negative, and going from not as steep to really, really shallow in its steepness. Now, what happens when you have a parent function and you have an equation where the slope, notice that the slope here is 0. Well, 0 times x takes that to 0. So here's what you have is you've got a y equal -3. Or what happens with a y equal -4, or y equal 5, or y equal 0, or we could even say what happens to y equal 2. All of these different values, whether you don't see an x as in the mx plus b form, we don't see a slope. We don't see a slope times x. That's disappeared in all of these. So really what you only see is the y-intercept. So let's graph a few of these with the calculator in regard to the parent function. So what if we said y equal -3? And I didn't put a variable inside there. So what happens when you have your parent function? Notice that we get a horizontal line. The horizontal line just indicates that there is zero slope. And where did it cross the y-axis? Was at 0, -3. So what if I chose y equal +3? Well, that would put the horizontal line above the origin at 3. Or how about another one? And we said y equals 6. Should be very similar to the y equal 3. It's just going to be a horizontal line crossing the y-axis at 6. And then if we chose y equal -6, we should see that drop below the line in green at y equal -6. So if you looked at the graph of the table of these, notice that what is the y-intercept? Well, the y-intercept of the parent function, which was the blue line. Remember, we have the parent function, and then parent function's y-intercept was 0. The red graph has a y-intercept of -3, so that would be 0, -3 as the ordered pair. What's the y-intercept of the black line? It would be 0, 3. Black line would be 0, 3. And then the purple would be 0, 6. With these, a little different than the parent function and different from the others that we looked at, is that this follows the y equals mx plus b. So what do they have in common? Well, each of these equations, what do they have in common? They each have a slope, and they each have a y-intercept. Slope, y-intercept. Slope, y-intercept. So those are things that they have in common, and then we'll see how do these relate to the parent function. So we'll start with the first one, y equals 2x plus 3, and we'll go to the calculator and we'll clear these out. And we'll say y equals 2x plus 3. We should see the parent function and then a shift up. So the 2 in the slope region, the slope of 2 just means it's going to be steeper than this one, the parent function. This is a slope of 2 to 1, but notice that the y-intercept has shifted up 3 units from 0. So what about y equals -2x minus 3? Well, then now you can start to think, well, that's going to be a negative slope because this one was a positive, and this should shift down 3 units. So y equal, the black line we'll say is -2x minus 3. We should see the graph go in an opposite direction and hits the y-intercept down at 0, -3. And then finally, we have a fractional slope. So we have y equals 4/5 x plus 5 and y equals -4/5 x minus 5. So let's look at the differences in those. In regard to the parent function. So I'm going to clear out some of these. So we'll have 4 divided by 5x plus 5. And so there's your parent function. And notice it's not quite parallel, but if we zoom out a little bit, we would see that they would eventually start to run toward one another. And over time, the red line is not as steep as the blue line. It started out higher on the y-axis, and that is due to the 5 being a positive y-intercept. The 4/5 is smaller than 1. The slope here is 1 to 1. This is 4 to 5. It's smaller than 1. So over time, it will not be as steep as the parent function. And then if we graph -4 divided by 5, -4 divided by 5, close it, -5, then we'll see that it goes the other direction. And you can always want a standard window. You can go to Zoom 6. Zoom 6 is a standard window. There's our parent function. There's our y equals 4/5 x plus 5. And here is our, well, I need a variable there. That's why that just didn't look normal. So let me go in here and insert an x variable, -5, and graph. There's the parent. There's the graph with 4/5 x plus 5, and here it is with 4/5 x minus 5. Notice the y-intercept and where it hits. These equations, what do they have in common? Well, we'll see that I can't graph that on the graphing calculator because it's in a function mode. But what we would have is with our x and y coordinate plane, this is x equals 0. So this is x equal 1, 2, 3, 4. So when x is 0, what we would see is a line that crosses through vertically through the origin. If I have x equal 2, then I would have a vertical line that crosses through 2. If I had x equals 6, then I would just know that at 5 and 6 down here, I would have a vertical line crossing through 6. Same as on the other side. If I had -2, well, x equal -2 is just a vertical line that crosses through the x-axis at -2. So these are all different. The others had y equal. Notice that those were horizontal. So what do these have in common is these are all vertical lines, which they're not functions. That's more, we can discuss that in class, but vertical lines in this case are not functions, and they have no slope, or also known as an undefined slope. Y equal 3. Is it a linear equation? Absolutely. It just means that for us to have just the y, that the coefficient of x had to be 0. So when that disappears, you're left with y equal 3, and it crosses the y-axis at 3. Is x equal 2 a linear equation? Yes. That's when the coefficient of y is 0, so that goes to 0, and you're left with x equal 2, and it crosses the x-axis at 2. So a vertical line will cross through the x-axis, and a horizontal line will cross through or intercept the y-axis. And then the final few slides is we're determining if, with given an equation, is or are the x and y coordinates, are they solutions of the equation? So there's different ways to do this. If I give you the equation y equals -x minus 5, I just want to know, are these two ordered pairs part of this? Are they a solution to this? And what that means is, we'll just do one, and then we'll look at the calculator for the rest of them. But is it a solution? Well, that just means you take the y value of -6 and you substitute it in. So -6 equals -1, which is the slope. That's understood to be -1. And we're going to substitute 1 in for x, minus 5. Well, -1 times 1 is -1 minus 5. -6 equals -6. You know what that means? That this ordered pair is a solution. That means it's on that line. So let's try the second one. -1, I substitute the -1 for the y value. -1 is my slope. I'm going to substitute -4 in for x and minus 5. Negative times a negative is a positive 4. And 4 minus 5 is -1. -1 equals -1. That tells me that both of these ordered pairs come from this linear equation. Now let's take y equals -2x minus 4. Y equal -2x minus 4. So let's go in here and let's just clear out all the equations. And we're going to type in -2x minus 4. And we're going to graph it. And we know it's going to be a negative sloping line and goes through the y-intercept at -4. So I wanted to know at y equal -2x, is 4 -10? So we've got 4 -10, and we've got -3, 2. So I just want to make sure that those are part of, well, what you could do is go to second graph and pull up your table and start looking. I'm going to scroll up to look for -3, and I see -3, 2. So that number, that ordered pair was given to us, and so it is a solution to this equation. But if I look down here, I see 4 -12, not -10. I should see I'm seeing 4 -10. That's the question. And -3 +2. And I see -3 +2. So one of those is a solution. The 4 -12 is not. So if we look again, let's try. Let's try this one. Y equals 3x plus 2. So y equals 3x go to my table, and I'm looking for -2, -4, and I'm looking for 3, 14. Those are the two ordered pairs. Well, we can use our calculator to check that. And so I got to type in the equation, and then I go to second graph, and I'm looking for -2, -4. I see it, so I know that that ordered pair is a solution to this linear equation. And then I'm looking for 3, 14. I see 3, 11. I was close, but 3, 11 is not. 3, 11 is a solution, not 3, 14. So that one is not, and that one was not. So your check for understanding. Number 1 would be name the quadrant for each ordered pair below. -4, 5 just means you're going left and you're going up. So that would be in quadrant 3. The second one would be 4, -5, which means you're going positive and down. So that would be quadrant 4. -4, 0, which means we go to the left 4, but then we don't go anywhere. So this one is not available. It's not in a quadrant. And then -4, -5, which means you go left and you go down, which would put you in quadrant 3. And actually this one would be left and up. And I said that was quadrant 3. That's actually quadrant 2. Sketch the following equations on your paper. Well, what we would have there is y equal -5. So on number 2, we would have y equal -5. And if we had to sketch that, we know that that's going to cross the y-intercept at -5, so somewhere down here. And it would be a horizontal line crossing at y equal -5. Well, what about x equals 6? Well, x equals 6 would be somewhere over here, and it would cross the x-axis at x equals 6. And then here with part C, we'll draw another one over here. And what I would have is this +4 would be up here at 4, but then we want to increase 3 and increase 1. Or we can decrease 3 and decrease 1. Otherwise, what I'm saying is that the slope is 3 to 1. So 3 to 1 or -3 to -1. And what you've created is a line that crosses through those 3 points. And then finally, one more. Part D is it crosses at -6, and the rate or the slope is -3 to 4, which means we could increase from this point, this y-intercept. We could increase 3, 1, 2, 3, but we've got to decrease 4. Or we could continue going down, decrease 3 and increase 4. So I'm kind of going off my grid there, but that line would cross through those points. And then you would determine on your calculator y equals 1/2 x minus 1. And you would just graph that. And that would be 1 divided by 2x minus 1. And we would graph it. Y equals 1/2 x minus 1. And what were we looking for? We're going to look for the ordered pair -3, 2. We're going to look for -1, -1.5, 4, 1, and 5, 2. So we're looking for those 4 points. Now, easiest way to do that would be to go to, once you graphed it, go to second graph and start looking for those ordered pairs. -3, -2. Well, this says -2.5. So the -3, -2 is not going to be a solution. Now we're looking at -1, -1, -1.5, -1, -1.5. That is a solution. So this one works. What about 4, 1? I see 4, 1. That's a solution. And what about 5, 2? 5, 1.5. So 5, 2 would not be a solution. So it would just be these two, -1, -1.5, and 4, 1. Those would be your solutions.